hello everybody. My name's Nicola. I run the Code Club Australia program, and we're running the virtual code clubs to try and keep you guys engaged and get coding at home. I first want to say thank you so much for joining me. I hope that you guys are having a good day stuck at home. And I'd like to acknowledge the traditional owners of the land that I'm on, which is the Gadigal people of the Eora Nation, and to acknowledge leaders past, present, and emerging of that First Nations community. And to welcome you all from the First Nations land that you're all on, and thank you for joining us. So we are going to do two things today. The first thing we're going to do is hear from my friend Tim, who's also on the call. And Tim's going to give us a 10-minute kind of guest speaking slot all about something really fun that we're going to talk about in a minute. And then we're going to do some coding. So Tim, it might have frozen on you. Are you still there?
I'm still here.
Oh,
good morning, everyone.
Okay.
I'm just being very quiet. Good morning, everyone. My name's Tim, and thank you to Code Club Australia for inviting me to come and talk to you today. I understand you're in Western Melbourne, so unfortunately in lockdown, so my sympathies to you. But I also understand that you're in a very aviation kind of area, so you're between Avalon and Tullamarine. I've worked in professional technology roles for 20 years, but the job I'd like to talk to you today is when I used to work at Rolls-Royce, and Rolls-Royce make a lot of engines for cars and aeroplanes. So who am I? I work in technology, and I used to code. I don't code anymore, but I used to code for about 5 or 6 years, and I want to talk to you about some of the projects I used to work on. So some of them around aeroplanes and flying really, really fast, and then also more recently in cars. I want to try and make this session as interactive as possible. So whenever you see a purple box at the bottom of the screen with a question in it, jump in the chat and type an answer to the question that I've asked. And then I'm going to tag team with Nicola, and we're going to go through some of your questions as you answer them. So what I'd like to talk about first of all is, what's the fastest speed that you think you've ever been in a vehicle or a car or a plane? And maybe if you could punch some of those answers into the chat, then I'll get Nicola to read some of them out as they come in. But what I want to try and talk about is speed and how sometimes technology and engines and engineering can be used to move us around and get us places quickly. Maybe not at the moment, but when all this is over, then quite shortly. So how quickly does an aeroplane go? So an average typical aeroplane, so an Airbus, for example, which is a very popular, or a Boeing, 903 kilometers an hour, which is really, really quite quick. Now I want to have a little bit of a competition with you. What do you think goes quicker, A, B, C, or D? Now, I haven't given you the answers to C and D yet, and that's part of the quiz. So C, you have the Formula One in Melbourne, and how quickly do you think a Formula One car typically goes? Now, the answer is 375 kilometers an hour. Now, D, this is the real test here. So this is a Concorde plane. Unfortunately, this went out of service 10 years ago, but it was a fantastic piece of engineering in Europe. I think it only came to Australia once, but it was a fantastic plane. Nicola, just going back to you with some answers in the chat. Do you have any input yet?
Yes, we've got a lot of guesses for D, for Concorde being the fastest. And some people have said 1,000 kilometers an hour.
Okay.
I think it might be a little faster.
Okay, so the answer is 2,179 kilometers, so really, really fast. So a quick fun fact, how much does an aircraft engine on an aeroplane cost? A lot of money is the answer, but $140 million per engine. Now, most planes have 2, and some big planes have 4. I was very lucky to work for one of the engine manufacturers, Rolls-Royce, in the UK, but there are other companies that make aircraft engines. Now, the company I work for, Rolls-Royce, also made engines that go in fighter aircraft, which was where I worked. So the next bit, I have to be very careful what I tell you because it's officially secret, but I can obviously tell you some of the publicly available information. So the aircraft I used to work on, and when I did my computer coding, I worked on this airplane for 6 years. Rolls-Royce make the engines that go in this plane, and there are two engines. You can see in the middle photograph at the top there are round circles at the back of the plane. That's kind of the exhaust of the engines, and there are two engines on this plane. On the right-hand side, you can see a front view of the plane, and you can kind of see a green circle at the top. That's the pilot's visor that comes down in front of the pilot's eyes, and there's a lot of technology that goes inside that device that allows him to essentially talk like Alexa or Google Home to his airplane to be able to guide and steer it around where he needs to go. And you can see another picture on the left-hand side there of the pilot's helmet. So this is a picture of the actual engine. Again, there are two in this plane, but there are 4 countries that go into making this plane. So again, jump into the chat. And this is a bit of a test to see if you can recognize your flags. There are 4 countries that partner to make these engines. All of them are European countries, so that's a bit of a clue. And then we'll get some answers from Nicola. So Nicola, do we have any guesses on the flags that we can see on the right-hand side?
We've got some people typing in the answers,
Okay.
but we do have Italy and Germany as 2 of the options, and the UK. Oh, and then someone's just put in the 4th one, which is Spain.
Excellent. All correct. Well done. You all know your flags, obviously. Okay, so the engine not only has gone into powering an airplane, but it's actually been used now as well to power a car. And for the last 120 years, there has been an international race to be the fastest at going in a car. And this started, probably 1898. You can see there was the first with a French car. And the record currently is held by a 1997 Thrust SSC. Now, there's actually a new car that's being built called the Bloodhound, and it's being built by an English company. And I'd like you to guess how quickly you think this car is going to go. So if you look at the record there on the bottom right, the record is about 1,130 kilometers an hour. So they're obviously going to go quicker than that. And I'm wondering whether you can guess how much quicker. Are they just going to go a little bit quicker or a lot quicker than that record? So Nicola, do we have any guesses?
Yes, we've got a guess for 1,360 and another guess for 1,400.
Okay. Any more coming in?
Not at the moment.
Okay, I can tell you it's actually going to go, if it's successful, is going to go quicker than both of those guesses. So let's look at the car itself. So this is a picture of the car. On the top left, you can see the existing record in 1997 by the Thrust SSC, the Supersonic car. And then in the bottom right, you can see how quickly they want the record to go. So they actually want to drive this car at 1,600 kilometers an hour. And you can see in the middle there's a little black triangle, a visor. That's the windshield of the car, and the driver sits in that little tiny little cockpit there. And here's some more pictures of the car. If you look at the picture on the bottom right, this car actually has 3 engines in it. It has a Jaguar car engine, it has an aircraft engine, which is the picture at the top, and then it also has a couple of 3 rocket boosters. So a bit like a SpaceX rocket or something like that, in order to give it a top up in speed, because No one of those three things can go fast enough on its own. So the question really now is, how do you test a car that goes that quickly, and where do you go to test it? So in 2017, so 3 years ago in the UK, the team took out an airport for a day in order to test it. But this airport is only 3 kilometers long in order to test it, and they were able to get it to a speed of 320 kilometers an hour, which is nowhere near what it should be able to do. But that's in order to prove that that the vehicle works and it can stay in a straight line and it doesn't do anything nasty. And then last year, they had to look for a much longer racetrack. Now, in order to do this, they took lots of photographs from space using satellites and looked for a number of flat, friendly, very secure and reliable racetracks around the world. And you can see that a number of them, probably about, 7 or 8 were in Australia, mostly in central and western Australia. But a number all over the world as well. So if you're very quick, jump in the chat and type how many answers, how many sites do you think, how many racetracks do you think the satellites found?
We've got some guesses for 60, 80, 40.
So the answer is 35. So what they were looking for is the racetrack had to be absolutely flat. It had to be about 20 kilometers long, and it had to be about, I think it was like 1 kilometer wide, because it needs to be very, very stable and secure for the car to go. So in the end, they actually selected a racetrack in South Africa called the Hankski Pan. Now this is a dry lake bed. It's actually so flat, it's flatter than a pool table or a snooker table. Now, so last October, so this was last year, you can see a picture of the dry lake bed there that they used to test this car, and a number of test runs over the period of a couple of weeks in order to do this. Now, this was a massive exercise in moving all of the test teams, the engineers, the support teams down there to do this. Now, this was only a test run to prove that the car could actually cope with all the stresses and the pressures. A lot of the challenges that have been solved in building this car have helped develop and progress engineering. Now, the speed they got up to last October, November was, you can see there at the top right-hand corner there, just over 1,000 kilometers an hour. And that in its own right is the 8th fastest car in the world ever. So it's still not number 1, but it's already at number 8. Now, the car has gone back to the UK in order to have its rocket boosters worked on now, because this run that they did last year was only with the aircraft engine that you can see there in the picture. So a couple of fast facts about this car, the Bloodhound. The temperature of the engine is actually twice as hot as the inside of a volcano, so 3,000 degrees Celsius, which is pretty hot. So the driver here, Andy Green, he's an ex-pilot from the Air Force in the UK. And the question, jump in the chat, would you want to drive this car? So that's a picture of Andy in the car there, and he's there with a Jaguar as well in the factory in the UK. So would you want to do this? This is a really, potentially a dangerous job. What do we reckon, Nicola?
There's lots of people saying no. We do have one person that said yes. They're pretty keen. Oh, a couple keen.
Good on you. Good stuff. Now, so Andy's been working as a pilot for many years, and I think he was involved in the original Thrust SSC as well. So he has quite a history being involved in dangerous speed activities, I suppose. So this is my final slide. Now, the point I wanted to draw here is this car goes so quickly that it can't use conventional brakes, because they'll get so hot in trying to slow down a car. It actually uses some parachutes, I think 3 or 4 that come out of the back. on an explosive charge in order to slow the car down, and it gets up to its speed very, very quickly. We're talking in less than 10 seconds getting up to over 1,000 kilometers an hour. So if you are interested in learning more about this, the race program has a massive educational support program, and over 2 million children globally have been following this in order to promote the development of engineering and computing and the interest in aeronautics and this kind of area. So that brings me to the end of my piece. So back to Nicola to see if we have any questions, and otherwise we'll get coding.
Perfect. Thank you so much, Tim. Does anybody have any questions? You can either raise your hand or type it in the chat or turn off your microphone and ask if you have any questions of Tim. I have a question for you, Tim. Would you drive the really fast car?
No.
How long would it take to build?
How long?
That's a good question.
That's a good question. So it's taken them probably 10 years to get to this point. Unfortunately, the biggest challenge they have is always around money. The actual engineering challenge is when you have the right people and you have the right resources to be able to do this, they've been able to solve a lot of those challenges. Good question.
Does anybody else have someone wanted to ask why it's called the Bloodhound?
I don't actually know the answer to that question. I suspect it's maybe, there's Bloodhound in the UK is actually a dog that sniffs things out. So it's a chasing kind of thing. I don't know.
I don't think it's a very fast dog, the Bloodhound.
I'd have to Google that.
We'll come back on that answer. All right, do we have one more question before we do some coding? No. All good. All right, excellent.
I'll be hanging around for the next hour, so if you do have any questions when you get coding, then we'll jump in then as well.
Yeah,